Hello again. We're going to look at finding some perpendicular lines. So the first one that I'm going to do, or the one I'm going to do in this particular example, I will do some others later. We're going to find the perpendicular line to the line 4x minus 2y plus 5 equals 0 that passes through the point 3,5. So with perpendicular lines, we know that if two lines are perpendicular, if we find the gradient of the first line, the gradient of the second line is going to be the negative reciprocal. So I'll just write that down for you. So if we've got the first line, we're going to call the gradient of that m1, we know that the gradient of the second line is going to be negative 1 over gradient of the second line. Okay, so if you're not sure of that, I would write that down, pause the video and write that down. Okay, so our first step is, got our equation, and we're going to need to rearrange it, because at the moment I've got the equation in standard form. I want to rearrange it so it's in gradient intercept form, or y equals mx plus c. So I've got this negative 2y here on the left-hand side of the equation. I'm going to put this over on the other side, and it'll make everything positive. So we've got 4x plus 5 equals 2y. Now because both sides are positive, we can just swap everything about. Plus 5. And now we want just a y, not 2y on that side. So we're going to divide everything in the equation by 2. So we'll have y equals 2x plus 5 on 2. And I'm going to leave the c value or the y-intercept as a fraction. Okay, now we can see from here our m value, which is the gradient, is going to be 2. Okay, so just write this out. Y equals mx plus c is the general form for the gradient intercept form of a linear equation. Okay, so our gradient is 2, and we're going to call that m1 because that was our first line, the line that we were given. Now we want to find m2, which is the gradient of the line perpendicular to the first line. So we know that m2 is going to be the negative reciprocal of m1. Now we knew m1 was 2. So m1 is 2. m2 therefore must be negative 1/2. Okay, so that's what we're going to be working with now to get the equation of our new line. We know m2 is negative 1/2, and we also know that this new line is passing through the point 3,5. So we're going to sub it into our formula. Now I'm going to use this formula. Y take y1 equals m, x take x1. And I'm going to sub in all of this information here. The point, which are x and y coordinates, and the gradient for that perpendicular line. So we've got y take 5 equals negative 1/2 x take 3. Okay, now we're going to just rearrange this. We've got y take 5 equals negative a half x, I'm just expanding this side here, plus 3 on 2. I'm just going to have to change the page because I'm running out of space here. And we've got y equals negative x on 2 plus 3 on 2 plus 5. When we move that negative minus 5 over to the other side, it becomes plus 5. So we've got y equals negative x on 2 plus 13 on 2. That's because 5 is going to be 10 on 2. Makes it easy to add your fractions if you have both the same denominator. So 3 on 2 plus 10 on 2 is 13 on 2. Okay, now I want to, because our question was given to us in standard form, we should give our answer in standard form. So we can see here, we've got denominator, we're dividing by 2. I'm going to get rid of that denominator and multiply by 2 for the whole equation. So we'll end up with 2y equals negative x plus 13. Now we're not quite finished. We need to get everything onto the left hand side of the equation and set it to 0. So we're going to move this x and the plus 13, so the negative x and plus 13 over the other side. So we're going to have x plus 2y minus 13 equals 0. And that's our equation that's perpendicular to the line we were given initially and passing through the point 3, 5. And then we're done.